Hi, welcome back to the shop. We started a new small project. For the small steam engine I'm building right now, I need some mean of turning eccentric parts, and a 4-charge chuck is fine for that, but most of the stuff I do is very small, and also the parts for the steam engine are very small, so I decided to build my own device for eccentric turning. And this is what I came up with. This is a miniature faceplate that bolts onto the spindle nose, and it has a single T-slot in it. The T-slot is exactly in the center, and it's machined to be 10 millimeters, exactly 10 millimeters. Very close fit. And what I'm going to make is an angle plate or a V block. It will sit on top of it, registers in the slot, and can be slid in and out. So it's very easy to center a part and to offset it by a given dimension using dial calipers, depth mics, or whatever you want. And I did this off camera because it's nothing special. It's just turning a big hunk of steel down, machining the centering recess and back, drilling and tapping the 10mm threads for the standoff bolts, and machining the 10mm T-slot into it. But now we need to make the angle plate, and I found this piece of 123/12 tool steel. This is pre-hardened tool steel. I used this also for the chuck jaws I made and for some other projects. I like this stuff. It's almost free cutting. It's pre-hardened and machined very nicely. And this is the top view of it, of the angle plate we're going to make. This is the fixed V block that goes on top of it, which will have a 10mm key on the underside. And this is the hold down, which can go in like this for small diameters down to 3mm, and can be inverted for diameters up to maybe 40mm. The V block will be held down with one single 8mm bolt. That should be adequate, and the hold down itself will be held in place with 2 6mm screws. And what else? Yeah, the design is a direct copy of the Keats angle plate. You can Google that. It's a very common design in model engineering for small lathes. The steam engine builders almost all know this design. And we will make one out of this block of tool steel, and most of the work I think we will do on the shaper. Okay, we have the block squared up all around, and should be to size, and the surface finish as usual from the shaper is pretty good. It's really not bad, and we're just going over to the chamfering machine and break down all the edges. There we go, all edges nicely chamfered, pretty fast, pretty even all around, and now we can proceed on. Okay, let's do some layout. First of all, we want the center line, and I'm using again the gauge block and the scribe for layouting. Because I still don't have a proper height gauge. And I'm especially looking for the mid-tutorial one with the dual round columns. Okay, we got the center line. Now we want the width of our V-notch. That's 20 millimeters, so center line is at 30. Half 20 is 10. 30 minus 10 is 20, so we use a 20 millimeter gauge block for the width of the V, and just flip it around and do the other side. Oops. Okay, now we have the width of our gauge of our V notch, and now we need the 45-degree angles, and I have a V block here. And this is another precision layout now, so we can use the good old stereotype gauge, or surface gauge as it's called. And we just set it to this line and scribe a line. Same on this side. And because everything's symmetrical, we can just flip it around and do our layout line on this side too. Oh. Perfect layout lines. Quite happy with it. Now we can machine out this V-notch. Yeah. And I just did a second set of lines because the V-notch just looked too small. Didn't look right with the 20 millimeter wide V-notch. Now it's 26 millimeters wide, and that looks way more proportioned. So let's go to the shaper and cut the material. Okay, I had to swing the vise around to machine the V cutout, and for this operation the vise needs to be trimmed. So let's do a quick trim of the vise using the dial test indicator. Just move it to a convenient number, hand tighten the screws and traverse across the fixed jaw of the vise. And yeah, this is 1 in 1,000. It's almost dead knots on. Great. Yeah, I wanted to show you how I trim the vise, but yeah. And it has full contact with the vise jaw, and it has travel in both directions. So no need to trim the vise here. Yeah, that's pretty darn good. Tighten it down and do a quick check if it moved. But this vise doesn't tend to move when you tighten it down, so no worries. Okay, we have the part already squared up in the vise, or at 45 degrees in the vise, and how I set it up is pretty easy. I used a V block, which is a precision V block, and I set it on top of the part, and then I had a level surface where I could indicate. I just used my dial test indicator like this, and traversed across the V block like this. Here you can see it again. I set the dial to 20 and traverse across, and there we are at almost 20 again. Okay, this should be good enough. Yep, 19, 19. Perfect. Pretty easy to set up something at 45 degrees when you have a pretty precise V block and your part is square. Okay, right now we're cutting the V groove and we're just roughing out the material using the power feet in the table power feet to work our way up against the scribed line I have there. I'm gonna take cuts of 1.5 millimeter depth there. So that's a pretty substantial cut for this machine. Okay, I got the V block finished and I checked it on the surface plate with dial test indicator, and it's on all dimensions within about 1/100th of a millimeter, except for the V slot itself. It's 7.5 hundredths offset to the other dimensions of this plate. But this doesn't matter very much because doesn't matter. This way, in this configuration, the V block will go on to this faceplate, and we want it to slide in this direction. And we're going to use this key, which is a very close fit in the T slot, to go on the bottom side of this V block, and I want to cut a slot in here where this key fits very close in. And yeah, this key needs to be centered to the V, or otherwise it's pretty useless. And it's I have an idea how to center on this. We're going to use a dowel pin hardened and ground. We will hold this in the vise, then we take this dowel, we clamp it in place with with a cam twist clamp or with a C-clamp or whatever. Then we can use our dial test indicator to center on this pin, and then we get the center of this V cutout, very precise, and then we can use that 0 to machine the slot for the keyway here, 10 millimeters wide, and I want this to be a really snug fit in the slot. So let's go to the milling machine and set it up. Okay, I have the V block already in the vise and it's clamped up. The vise is of course trimmed, and now we're going to use a C-clamp to hold this pin in place so we can indicate it. Okay, I already centered on this dowel pin. I just went down with the indicator and spun it around until I got an even reading all around. Now we can remove this whole setup stuff, and machine our 10mm keyway slot in there. Okay, 6mm through flue covered end mill I touched off, and we're going to cut this slot only 1mm deep. Okay, should be the ticket. Oh yeah, this is really perfect fit. No wiggle at all. Yeah, that's fine. Okay, little time warp. I finished the V block. In fact, I just added these threaded holes. I took a key, I drilled it and screwed it into the slot we just machined. Then I relieved the back side of this V block just to make it look nice, give it a good appearance, almost make it look like a casting, and also reduce the weight a bit because this thing will rotate off center on the lathe, and if we make it a bit lighter, we help with the machine that way, so it doesn't wobble around. And that's how the V block fits onto the faceplate. I made a T-nut, and when I use a long screw, I can reach through the V block and into the T-nut, and I can clamp the V-block in position. And as the V-block is guided by the key, the adjustment for eccentricity is very easy. It has only one degree of freedom, so it's very easy to align. Normally a keyed angle plate it's just bolted to the face of a normal faceplate, and it has 2 degrees of freedom, and it's really hard to set up and quite tedious. So this is, in my mind, pretty much an improvement. And now we just need some kind of a strap clamp or a clamping bridge, or however you want to call it, to hold the workpiece in the V groove. The most simple form would just be a piece of flat material with 2 bolt holes that can be screwed on to hold the workpiece. Then you can set it center or off center as you want and do your machining. Okay, we're roughing down a piece of tool steel that will be the strap clamp for the V-block. It's the same pre-hardened material I also used for the V-block itself. It's a nice material, and I had a piece about the right size, and we're running a 30mm shell end mill high-speed steel at 200 RPM under power feed. Let's go. I have roughed down the block of raw material to final size, so it fits like this. And as you can see, this is quite a chunk, and there's a reason to it. Right now I couldn't clamp, say, a screw like this because the screw is, due to its small diameter, below this surface, so you can't clamp it. And for that reason we will design the strap clamp like this. This blue material all will go away, and then we can just, this pyramid shape will engage into this V cutout and can clamp smaller diameters. Okay, we have a 3-flute carbide end mill 10mm in our spindle, and now we will go down almost the full 13mm, and we will just hog away the material until we are almost at the pyramid, and then we will tilt the part 45 degrees and cutting this end mill at 1000 RPM. Okay, we just hogged away most of the material, and we took the full 13mm depth of cut at once, and we got incredible nice chips. Okay, and we made a mess of nice long chips. By the way, these chips really hurt if you get those stuck in your finger, so don't play with them. Okay, we drilled our 2 clearance holes for the 6mm clamping screws, and now we will change to a counterboring tool, and give these bores a light counterbore. This is just purely for optics. You don't need to do that. And that's really only because I like the look of it. There is no real technical purpose for these counterbores. And we will add some on the other side too. We cannot rest this piece that way on parallels because it's pointed, so we will hang it on the parallels. We'll lay down the parallels on top of the vise and clamp it like this, and the parallels will support the part for counterboring. This would not be an ideal setup for milling, but for counterboring it's perfectly fine. There we go. We'll clean up the surfaces just for appearance. I have 180 grit emery cloth here, and I will put it over a flat file. We'll just clean up the surface. Okay, and this is how it looks finished. We have the strap clamp on our V-block, and we can reach down into the V to hold small diameters. And just to see how small, I have a piece of, this is 2mm drill rod, and we can perfectly hold this, perfectly clamp it. There we go. Nice and secure, and if you're worried that you might damage the surface, you still can put in a piece of brass shim stock. Now you can set your offset from the center, lock it, and do your machining. And now we go to the lathe and we'll just turn a piece for fun. Okay, we're over at the lathe and we're just about to set this thing up. Okay, just tighten down our 3 bolts. And now, with the use of the indicator here, we can determine the overall total throw of the later crankshaft or the crank. I zeroed it down here, and when we come up, we have about 3 millimeters, but we want only 2 millimeters, so zero it and give it another spin. We have 1.7. That means we have to go down . Yeah, 1.95. Yeah, this is 2 millimeters pretty much. Now we can clamp our angle plate with the screw. Okay, put on your hard hats, we do a speed test. We see how this behaves when we run it up at quite some RPM. Let's start slow and crank it up. Okay, we go up to about 1000 RPM. Okay, we didn't get much vibrations at all. In this configuration, this offset, this angle plate and the V block and all the stuff on here is pretty much balanced. There is only one spot where I got vibration, and that comes from the motor. I have that also when I run the 3-jaw chuck on this machine. The whole machine gets in a band of about 10 to 20 RPM into harmonics and starts to swing, and you have to skip that that speed. It's only a very small band where it gets into harmonics, but that's not the fault of this off-center chuck. So we can run this at pretty high speed, but yeah, the V block is held on with one 6mm screw, which can exceed quite a lot of force, and the part is held even with 2 screws, and this is also very secure, and the whole chuck will also not come off as it's held in place with 3 10mm studs, but still you might be better off playing on the safe side and not max out the speed with one of these. That's a bit of a heavy cut. Okay, there we go. That's our crank pin. Let's take a closer look. You saw that the machining went very well. At the beginning I was taking a bit of a heavy cut for this much overhang and I got some vibrations, but I backed off and everything was good. And what you can also do is you can use this if you want to work on you want to set a part to run through. Like you would use a collet chuck, but if you don't have one, you can use this. You clamp your part and then you can adjust it for zero run out, as precise as you want, and then you can do your machining and be happy. Also, it's interesting when you use a tool post grinder because there are no moving parts in this. When you use a 3-charge chuck for grinding, you have to take it apart and clean it completely because of all the grinding dust. And taking a 3-charge chuck apart is not the most fun activity. This thing is cleaned in a few seconds. This is a piece of tooling you can blow off compressed air without any worries. No worries there, because there is no moving parts where you can blow stuff in. So you can also hold square material, center and off center, like you want. And this thing has quite a lot more uses. So you will see this in future build videos of mine, and until then, thank you for watching. See you next time.